All right, here's the last part of lesson 9.1. The sine and cosine functions are related to each other using the Pythagorean identity, which we know as a squared plus b squared equals c squared. So we can prove this, but you can accept it also, that sine squared plus cosine squared is equal to 1. That is the idea of a squared plus b squared equals c squared. If you think of it like the unit circle, and you have a unit circle, see how nicely I can draw this, that you have a right triangle here that represents a point. And we know that the x coordinate is cosine, the y coordinate is sine, and that the hypotenuse of the unit circle is 1. So we would know that it would be a squared plus b squared equals c squared. Well, in this case, in terms of the unit circle, it's cosine squared plus sine squared is equal to 1. And here they could put in either add, and you can add in either order. You could also rearrange it. So notice, are they the exact same thing? Sine squared plus cosine squared. Oh, this is just using a different variable. Notice we could also rearrange it. So if I wanted to know what sine squared equaled, you could just simply subtract cosine squared, and that's also the Pythagorean identity. It's just that you rearrange the identity. You could do the same with cosine squared. You would subtract sine. So you could use and manipulate this identity to help you. So, saying that, it says use the Pythagorean identity to rewrite this equation to help us solve it. So 2 cosine theta minus sine squared theta is equal to negative 2. The challenge with this is that we have two, I'm going to use a pen, black pen here. We have two different trig ratios, cosine and sine. I only want one so I can solve it. So, do you know what sine squared? I can take the Pythagorean theorem, see sine squared, and instead I can replace it with 1 minus cosine squared. And why would I do that? So that I can solve it using only one trig ratio. So, substitution. So where there's sine squared, you plug in 1 minus cosine squared using the Pythagorean identity. Now we just have cosine. Now I can do something. So what do I recognize? Well, one thing I recognize is that it's a quadratic equation because of the squared. I'm going to distribute and make it equal to 0. So let's distribute. Negative times 1 is negative 1. A negative times a negative is positive. Cosine squared theta, and that's equal to negative 2. I want to rearrange this equation to make it equal to 0. So to do that, I'm going to have cosine squared theta first, then plus 2 cosine theta, and then I have negative 2 and negative 1. So I'm going to add 2 to make it equal to 0. So negative 1 plus 2 is positive 1. And now I'm going to solve this quadratic. I want you to think of this quadratic the same way you would think of x squared plus 2x plus 1. If it was something that simple, you'd think, how would I factor that? What two numbers multiply to 1 and the same two numbers add to 2? So you recognize that as plus 1, or you could write that as plus 1 squared to be able to factor to solve it. So instead of x, we have cosine theta. So same idea. So here we have cosine theta plus 1 squared. So think of cosine. In this example, you let cosine theta equal x. So instead of cosine theta, think of it as just x. Think of the algebra when it's really basic, like Math 1 or Algebra 1, and then take out the x and put back cosine theta if you like, and now solve it. So to solve this square root, well, the square root of 0 is just 0. It's not positive or negative. And then subtract 1. So there's only, and we're looking for the answer between 0 and 2 pi. So what's our understanding here? Cosine goes with the x coordinate. So where is the x coordinate? Negative 1. That's to the left. So I think of the unit circle, negative 1. That's way here on the left, right? So that answer is going to be pi. If there is no restriction, there would be an infinite number of answers that could be correct. They say use your calculator to verify your solution. That means go back to the beginning, where there's a pi or where there's a theta, put in pi, and just type it in and see if it equals negative 2, and it does, to make sure it works. So you can try that. All right, assignment 9.1, pre-calculus doesn't mean it's easier than calculus. It just means that there's work before calculus we need to know, a foundation. So this is trigonometry foundation, and we're going to do a quiz on this next class.